All right, hey, back to the homework videos. We're going to do page 136. Page 136 is where we started talking about inverse trig ratios, inverse sine, inverse cosine, and inverse tangent. And we use those to solve for missing angles. So instead of the problems from before on page 134 where we knew the angle and we had to find a side, for these problems we know two sides and we have to use the sides to find an angle. So let's talk about some of these. Make this bigger. All right, that'll do. All right, so the way we do these is very similar to how we do the other kind of problem, which is where we just kind of, we look at the angle that we're given and we label the sides. 15 here is opposite from x and 24 is the hypotenuse. So since we're working with opposite and hypotenuse, again, we would go back to SOHCAHTOA and we would try to figure out what to use. Do we want to use sine or cosine or tangent? And since we've got O and H, it seems like we want to use sine. So we know that the sine of angle x has to equal the opposite side, which is 15, divided by the adjacent side, the hypotenuse, which is 24. And again, there's two ways to do this depending on what kind of calculator you've got. If you only have the calculators that I'm lending you out, the ones that don't do sine, cosine, and tangent, then to solve this, I would figure out what 15 over 24 is as a decimal. And so that means you do the division. And 15 over 24 means 15 divided by 24. So you can type that into your calculator, even if your calculator is just sort of one of the basic ones. One like this. So I'll bring that over. And let me see. Well, that's weird. Yeah. Let me just fix that. Alright. Alright, just pretend that you don't see a sine button over here on this calculator. Just pretend we don't have that. And we'll act like we don't. So what did we just say to do? We said let's do 15 divided by 24. So 15 divided by 24. That's going to give us some decimal, 0.625. So the idea is we would take that decimal, 0.625. And we have to figure out what angle has a sine that equals 0.625. And there's no way to do that without a calculator other than to just go to our trig tables again like we do. So if you're looking in the sine column over here for these first 30 angles, those are all too small. So hop over here. We're looking for 0.625 and I see it. 0.625 would be right here between 38 and 39. So we can see that there. And so if you don't have a calculator, then you can just give me that window. You tell me that we're somewhere between 68, 38 and 39. Got it. Whoopsies. Boop. 38, 39. And that can be the end of the problem. That's fine. You say, okay, x is equal to something between 38 and 39. And that's good enough. If you give me that, that's fine. But the other way to do this for real, is you kind of take the inverse sine of both sides. Now the inverse sine of sine would cancel out and just leave you with x. You bring the x down. But whatever you do to one side, you do to the other side too. So over here, x would equal the inverse sine of 0.625. And on the fancy calculator, this one, we can type this in exactly the way it looks. To get to inverse sine, you have to hit the blue second button. You go second sine, and then you get sine with a little -1 on it. And you can type in the decimal 0.625, or you can just type in the division problem, 15 over 24. And your calculator will do all the work. Press enter, you get 38.68, and that's it. So again, notice that the answer we got is actually in here. It is between 38 and 39, just like we hoped it would be. So you could do these problems either way. I hope everybody got the message that in the homework we are only doing the odds, so you don't have to worry about doing number 2. There's just too many problems and it would get a little repetitive. Now if you want to do number 2 because you need extra practice, go ahead and do it, but the only thing I'll grade you on is the odds, so just make sure the odds are getting done, but you don't have to do everything. So I'm going to do 3, we'll make it bigger. And it's going to be the same as the last one. The first step is going to be mark your angle and then mark the sides. Opposite from x, I see a 20. Adjacent to x, I see a 37. And I don't have a hypotenuse. Opposite and adjacent tell me I want to use tangent. So the tangent of x must be 20 over 37. That tells me that x must be the inverse tangent of the fraction 20 over 37. And my calculator tells me that the inverse tangent of that fraction is, let's see, second inverse tangent of 20 over 37 is 28.39. And that's it. We could do 4, but I said you only have to do the odds, so we'll move on. Let's do 5. Alright, for number 5, find your angle, mark your sides, write your equation, and then solve it. I see x here, and opposite from it is the 40, and this 41 is our hypotenuse. So O and H, that's sine, SOHCAHTOA, so SOH. So the sine of x must be 40 over 41. And I'll do this one the other way. Remember the other way to do this was turn 40 over 41 into a decimal. So if you do 40 divided by 41, then the decimal I'm getting is 0.9756. So that means I can run to my table of values and look for 0.9756. So that's here. Calculator's probably in the way. Whoops, we're looking down the sine column for 9756. So yeah, we're going to be over here for sure. And as I go hunting, here's some 0.8s, some 9s. There's 97, 974, 9756 would fall between these two. So we're going to be between 77 and 78. And again, you could stop there if you wanted to, but since we have the technology, we should probably do better than that. Let's just check our calculator. I'll clear all this stuff out, and we're going to do inverse sine of 40 over 41. And we get a more precise answer. We get 77.32. And so that narrows it down even more. We're not just somewhere between 77 and 78 anymore. We know that we're right on 77.32. Okay? So number 7 is different. We're back to kind of a mixed review now. So number 7, we are not solving for an angle. So you shouldn't expect to use inverse trig this time. You're going to use normal trig. So I see this 39. I go opposite. I go adjacent. That tells me we're writing a tangent. But we're not doing the tangent of x this time. We're doing the tangent of the actual given angle, the 39. And it's going to equal 11 over x. So we're back to kind of normal trig like we had in the last homework. I'm going to put this over a 1. I'm going to cross multiply. I get x times tangent of 39. And that's going to equal 1 times 11, which is 11. So now to get x alone, I have to divide both sides by the tangent of 39. And on this side it cancels. On this side you get 11 over tangent of 39. So if I didn't have a calculator that could handle this, then I would look up tangent of 39 on my chart. So we'd go find 39 degrees. It's right there. And we'd look for the tangent of it. That's the last column. And I see 0.8098. So I know that the answer to the question is just 11 divided by 0.8098. Am I saying that right? 8098? Yep. So just do that. And again, no matter what calculator you have, you'll be able to evaluate that. So clear everything and type in your 11 divided by 0.8098. See what you get. We got 13.58. Yep. So x is approximately 13.58. That's it. Let's see what number 9 is all about. So number 9 is another one where we're solving for a side. We don't have to find an angle, we just have to find a side. So we don't have to do any inverse trigonometry, we just do normal trigonometry. And for this one, looking at it, hopefully you're getting good at this by now. You can tell that this is going to be tangent because we see that opposite side. Ooh, opposite side. And we see this adjacent side. So that means we want the tangent of 51, and it's going to be equal to 8 over x. So solving this one's going to feel like the last one. Put this over 1 and cross multiply. You get x times tangent of 51, and it equals 8. So you divide. You get x equals 8 over the tangent of 51. And we'll solve this one the easy way by just typing the whole thing into the other calculator. This one. And I can literally just type it in exactly how I see it. I can go 8 divided by tangent 51. And that's it. Hit enter, and I'm getting 6.48. And that's a wrap on number 9. We don't have to do 10 because we're only doing the odds. So let's go check out 11. So you'll notice for 11, x is an angle again. So this time we do need inverse trigonometry. But I'll still start the same way. Here's my angle. And 14 is adjacent. 22 is hypotenuse. So this is going to be a cosine one. So we'll do the cosine of x. Set it equal to 14 over 22. And that's telling me that the cosine of x is equal to whatever 14 over 22 is, which my calculator tells me is 0.63636363. So if it's 0.6363 forever and ever, then we can go find that on our chart. So go to your table. You're looking down the cosine column. All these cosines are too big. Over here, yep, we're going to get small enough because here's 0.7, 0.70, 0.69. We're looking for 0.636363, so we found it. It's going to be between 6.4 and 6.2. So that gives us an angle that's between 50 and 51. So you can tell me that x is just some angle between 50 and 51. But as I've said before, I would much rather you told me that x is the inverse cosine of that decimal, the 0.636363, or just use the 14 over 22, that's fine too. But either way you slice it, we should be getting a final answer of second inverse cosine 14 over 22. 50.48. And that does work for what we thought it was. We knew we were between 50 and 51, and there we are. What about 13? More of the same. Looking at 13, we're solving for another angle, so you're going to use inverse sine or inverse cosine or inverse tangent. And we've got adjacent and we've got hypotenuse. So this is a cosine one. And we'll say the cosine of our angle x is equal to 31 over 36. So that means x is just going to be the inverse cosine of 31 over 36. And I'm going to do it the easy way again. Just use my fancy calculator. Clear. We want inverse cosine 31 over 36. And it looks like we're getting a 30.56 degree angle. And that's it for 13. Let's go to 15. All right, so 15 is one of these trickier problems where we've got a quadrilateral formed by two different triangles. I can't tell if I need this to be bigger. Maybe I do. So let me grab it, make it a little bit bigger. All right, here's a bigger copy. We'll make it real big. All right, so how would we do this? They want us to find DE. So if we're trying to find DE down here, we'll call that X. And I'm pretty sure before we can find X, we're going to have to find something else first. So what we need to find is the side that these two triangles share. And so up here in the top triangle, we've got the 61 degree angle, and this side that's 24. Well, the side that's opposite from that, let's call that Y. And like I just said, that makes that one opposite, and the 24 is adjacent. So I can use this top triangle to figure out Y, and I'll do it by writing a tangent equation where tangent of 61 equals Y over 24. So that means Y is equal to, now we'd cross multiply, right? We get 24 times tangent of 61. And according to my calculations, that would make Y 24 times the tangent of 61, which is 43.30. 43.30. And then the deal is, I can now use Y to figure out X. Now things have changed because in the bottom triangle, X is opposite from 19. But Y, which used to be opposite from 61, Y is now adjacent to 19. So since in the other triangle we're working with opposite over adjacent, we are going to write another tangent equation. We'll say the tangent of our little 19 degree angle is going to be equal to X over. Now technically it's X over Y, right? But we just solved for Y. Y is 43.30. So we're going to be able to solve this by just multiplying both sides by 43.30. We were cross multiplying essentially. We're going to multiply by tangent of 19 and just set that equal to X. And our calculator will do that work for us. In fact, we still have the 43.30 in our calculator. So if we just hit times, it'll grab that old answer we already had, and we can multiply it by 19. And our answer will be a little more precise if we do it this way. Because notice, if we typed in 43.30 and multiplied that by the tangent of 19, let me see how much we're off by. It can sometimes be a lot. Here it's no big deal. We're getting 14.91 either way we do it, but sometimes that's something to be concerned about. But we're fine. We're getting X equals 14.91. Okay, that's 15. We are allowed to skip 16, so we're going to 17. It says a ladder is leaning against a wall, so we're into word problems, which we kind of already did. We did some of these on the review, but I'll do this one again, no big deal. I don't know why I'm making it smaller. Let's make it bigger. It says a ladder is leaning against a wall. It makes an obtuse, or it makes an angle of 75 with the ground. If the foot of the ladder is 60 from the base of the wall, what is the length of the ladder? Okay, let's draw this. Let's pretend we have a nice grassy yard. Let's pretend that in that yard there's this big old brick wall. So, big old brick wall. Oh well. Now, leaning against that wall is a ladder. Boop, 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 boop. I don't know why I'm drawing a realistic drawing. I just want to. All right. So, what does that mean for us? I think it means that where the ladder hits the wall, we come straight down. Where the wall meets the floor, that's a right angle. Where the floor runs to the ladder, looks like we got ourselves a right triangle, right? So I could take this blue right triangle. Let's just pull that out, label all the important stuff. Here's the height up and down the wall, which they said was nothing. They didn't tell us anything about that dimension. Here's the distance across the grass, which is, well, that's the 6 feet. It said that the ladder's base is 6 feet from the base of the wall. So from base of the wall to base of the ladder, that's 6 feet. They also told us that the ladder makes an angle of 75 degrees with the ground. So I know this is 75 degrees. So the question is, do they want me to figure out how far up the wall the ladder reaches? We could call that x. Maybe they want that. Or do they just want us to figure out this hypotenuse? And the answer is, they're saying, what's the length of the ladder? Well, remember, this thing's the ladder. The thing I marked as y. So it's definitely our job to solve for this hypotenuse, because that's the actual length of the ladder. So that means that when we're doing this problem, we are going to ignore the heck out of that thing. But this guy, the 6, is adjacent to our 75 degree angle. And of course, y is the hypotenuse. So as soon as you know that we're talking about adjacent and hypotenuse, you know that we got to do cosine. Move the calculator. We're going to write a cosine equation where the cosine of 75 is equal to 6 over y. So if you cross multiply, then the y just comes over here as a coefficient on cosine 75. And the 1 times 6 is 6. So to solve, we would have to divide by cosine 75. And of course we do that on both sides, just like everything else in algebra. And the cosine 75 here cancels the cosine 75 here. You have plain old y. And you can use your calculator to figure out what 6 divided by cosine of 75 is. So type that in, 6 divided by cosine 75. 23.18. Now, remember with word problems, you are given units. It says right here, 6 feet, right? So we know that these measurements are in feet. So when you give me your final answer, you should make sure to include your units. If it's feet, if it's inches, if it's miles, whatever it is, you got to actually show me that you know. We should be pretty close to done, right? Oh, we are officially done. All right, that's 136. Remember, you do not have to do the evens, but it's not a bad idea to do the evens if you think you need some extra help. So just do your best. I'll see you Monday. Hopefully these videos are helpful. Bye.